2.1, adding and subtracting vectors. So welcome, most likely watching this at some point early on, either probably in grade 12 or in your first year, and you are kind of either reviewing or learning about vectors in general. So what I want to talk about in this video, it's probably going to be part 1 of 2, is adding and subtracting vectors. Now, when we're just adding and subtracting scalars, and the easiest way to think about it is when you are dealing just with numbers, we don't think much about addition and subtraction, because when you are discussing scalars or just numbers, for example, we take it for granted, right? So if we say 1 plus 1, it equals 2. If we say, 1 minus 1, it equals 0, and so on. Now, when you're going to be doing that with vectors, it is a little bit different because vectors do have a direction. Luckily, once you start understanding it and get a little bit of a perspective visually, especially in 2 dimensions, which is what this video is going to be about, you can expand it to further dimensions if you like. Once you get that grasp of magnitude of vectors, okay, and then the actual direction, okay, the addition and subtraction is not really that big of a deal. So I'm going to talk about that and then how you can think about the addition and subtraction. Okay, if you do take 2 vectors, and here you have, I call them V1 and V2, then, I'm going to discuss what happens when the vectors are perpendicular to each other. So you can break it down in terms of kind of horizontal and vertical vectors, right? And those are the easiest ones to talk about in terms of adding or subtracting, okay, and then what you might want to do with them. Then, of course, they're not always going to be perpendicular. So it might happen that they're just kind of general vectors. And in those circumstances, I love to break things down geometrically and take the x and the y coordinates of the vectors. And then the addition and subtraction kind of just falls apart. That's actually not bad, so long as you still remember your sines and cosines, okay, when you are thinking back to trigonometry. So let's get this thing started. Okay, it might be a little bit longer, but hopefully you will learn something and it will allow me to explain these concepts. So I'm going to just take, the first idea with respect to just additions and subtractions, so this one. And if you're taking any vectors at all, okay, so within here. So if you have a vector, and it doesn't really matter, so we can have this vector, okay, so we have its tail, so this is the end of the vector, this is the head, okay, if we are drawing it out, and this one I'm going to call V1, okay, let's say that this is what I have, so this is one of the vectors that I have, and I'm going to assume that they're kind of in the same direction for the moment. You'll see what will happen later. Now, if I take another vector, okay, and then let's say this vector is right here, maybe this one is a little bit longer. I'm going to just count that the squares that I have in there is actually the length or the magnitude of it. The direction in this case is basically, to the right. You can certainly call it, okay, if it's east, or 0 degrees to the horizontal. So let's say, this one I'm going to call V number 2, okay, in this direction. And again, so you have your tail right here, we can even put a dot there, and then you have your head at the end there. Now, if I wanted to be able to add these 2 vectors, right, so if I want to be able to add them up, it doesn't really take much. You can certainly take the vectors and, side them side by side. So basically, you will line them up from, head to tail or tail to head, okay, as you have it right here. So in this case, it would be the head of the first one, attached to the tail of the second one. And now we would have, an actual result from the entire thing in terms of the addition. So the addition, okay, if I would have it, would have been this entire vector. Now, of course, these ones are in exactly the same direction. So they're basically just horizontal in this case. And this would have been the addition of the 2. So this is V1 plus V2. Okay, and then that would be your full out vector. So it would have the same magnitude as the addition of those 2. So the magnitudes would just simply be added. And if you were thinking about the magnitudes just on their own, you would have just simply said, all right, so let me just add up the magnitudes because the directions are the same. And then there's really no issues here at all. and then I can count up, okay, so how many did we have? So this one was kind of 1, 2, 3, 4, 5 squares for the first one, and then for the second one it was 1, 2, 3, 4, 5, 6, 7, I guess 8. So, 5 plus 8 would have been 13 squares in total. And I have my full vector, and we call this the resultant vector. All right, so when you're going to be adding them up, so resultant vector, sometimes it's just called R, okay, with the little arrow up on top there, and that would have been the resultant vector for the two. That is, of course, if they're in exactly the same direction. Now, what happens, if we wanted to be able to see this and then say, well, wait a minute, what if I wanted to subtract this now? So instead of adding this up, what if I wanted to be able to subtract this? So let me add another page here just so that I don't run out of space. If I take the same two vectors, and then now all of a sudden, so I'm going to just kind of copy them down maybe. Let's do that. So if I take this, I'm going to remove this tail and head. I think you understand, okay, the difference between those. So let's say I have my first vector right here, but now I wanted to be able to subtract that second vector. And maybe what I'm going to do is I'm going to just kind of shift it, move it in the middle in there. So here's my, second vector that I have right there. I'm going to duplicate it. Okay, and so I can't kind of line them up one to the other because I'm not adding them. So what would subtraction mean now if I was doing this? So if I say V1 and then subtracted V2, what does this actually mean? Well, it's not just like numbers. So we do like to sometimes rewrite this, although the meaning, once you see it once, you don't really have to stress out about it. We like to rewrite it in this way. We say, our first vector, and then we're going to be adding, but that negative or that subtraction, we're going to bring inside of here. Okay, and then we're going to put it right there, and you're going to say, well, that's the same thing. Yes, you're correct. However, when it comes to vectors, this, okay, if you write a vector in this form, this is actually the opposite, right? So this is the opposite vector. So it takes this vector, and if you're thinking about the opposite vector, well, what it's going to do is it's going to flip it, right? So it's going to be actually not looking in terms of the direction to the right or east. It's going to go west or to the left. It's going to have exactly the same magnitude, but it's going to flip, okay, all the way around. And that is pretty interesting to be able to see that. So the negative of this, maybe I'll use a different color. So what's going to happen is you're going to flip this around, okay, and now it's going to go in this direction. And that is now your vector, and this is your V2 negative, right? So this is just, that negative just means that it's the opposite. So how would I be doing that subtraction? Well, that subtraction, if you're going to be lining them up, you will notice that, let me maybe remove this one right here, so the original one. So if I would take this, and then I would line them up, I'm not going to put them on top of each other, but you can see what would happen if I did, right? So if I just put it just below, and if I wanted to take one and then subtract the other, my resultant vector right here is going to be whatever is left over. I'm going to do it actually in red in here. So my resultant vector is going to be just this small little piece right here. That's going to be my resultant vector, which is left over. So that resultant vector that I have, it looks like it's 3 spaces. So this is how it would be. And that is the subtraction. That is what is left there. This is my resultant vector of doing V1 and then taking the subtraction, and this would have been V2. All right, so there you have, okay, that particular result. So additions and subtractions are not bad. Of course, the assumption here is that they're in exactly the same directions, right? Or at least they're 180 degrees to each other if you take the opposite. So it isn't really bad to think about. Now, in general, if you're going to be taking these, you don't always just have them in one particular direction. You might have a vector, one is maybe horizontal, the other one is vertical. So that can happen as well. But it doesn't really change anything for us. So if you were doing this, let's say, now I'm going to go back in here and I'm going to change these around. And let's say my vector number 1 maybe was something like this. So I'll still keep it horizontal. But then my vector number 2, okay, that I have, maybe it was actually vertical. Let's say maybe it was something like that. So this is what I would have. This would be my vector number 2. And now what would happen in terms of additions? Well, so if you're taking this, we can shift this. I have a nice grid in here, so that's great. You still take them, and if you wanted to do that, you would put them in this way. So you'd put the head of vector 1 and then the tail of vector 2, and this would have been still your addition. So this is still v1 added to v number 2. And now your resultant vector that you have, it would be, okay, so this is the resultant vector that you have, actually would be now at an angle, right? And so finding this out, okay, if it was on an angle is now a little bit trickier because they're not just in the same direction, so this resultant vector that I have in here, so sure, we can find out what its magnitude is if we know what the magnitude of v1 and v2 are. We certainly know the directions, okay, so directions are very easy because I drew them out. So how would I find this now, the resultant vector? Well, you have to kind of go back in here and you have to find out and do a little bit of math with respect to a little bit of trig, or at least triangles in here. So for instance, as you can see here, I'm going to just count the squares, and we can assume that the squares are actually distances. So maybe 1 square is 1 meter. So if I take the magnitude over here, that would have been 1, 2, 3, 4, 5. So let's say this is 5 squares. I'm going to call this 5 meters. And then I have, okay, my vector number 2. If I take its magnitude over here, it's going to be 1, 2, 3, 4, 5, 6. All right, so this is, let's say, 6 meters. Now, if I have this, then of course we can find out what the resultant vector magnitude is. That's just by Pythagorean theorem, right? So this isn't anything special. This would have been just 5 squared plus 6 squared, because we're just finding the hypotenuse. And this would have been just the, square root of that. So this is 25 plus 36, square root of this. Let's see if I'm still pretty good at the additions and subtractions. So 36 and just 5, I guess that's 61. So this would have been 61, or the square root of 61 meters, and of course it's still positive. That is that. But now the question, of course, arises is, well, that's great. You have found out what the actual resultant magnitude is, but we have to know what the direction is as well. Now, it's easy to see the direction for V1 and V2. V1 is east, or at 0 degrees. V2 is basically at 90 degrees from the horizontal, so that's not a big problem there. But my resultant one is not going to be that easy, right? So in this case, I do have to find out what that angle is. If you're thinking of this, okay, so going back, you can think back of your trig, right? So this is going to be, I'm going to put tan theta is equal to, and recall, so this is opposite, okay, over adjacent. So opposite over adjacent, which is nothing else but just 6 over 5. And then I can find out, okay, and by taking the inverse 10, what my angle would be. And now we can keep these out. So this is going to be the inverse, sorry, this is the 10 inverse. So we want to find this. This is going to be 6 over 5. Okay, what does this equal? Okay, so it equals approximately, 50.19 degrees, okay, in here. So that's how we can find out what the actual resultant is. So my resultant right here in the addition, if I was doing this, I would say this is square root of 61 at, and now, of course, we can put it in different forms. So in here I found 50.19. So I started from the east, and I'll put it in the quadrant bearings. So 50, I'll just round it off to the 1, and then I am going actually north. So there you have it, and now this is your full vector. So that would have been the addition. So adding up the vectors, is you can just put them directly, you know, head to tail, okay, and then go ahead. Now, what happens, you know, if it is the subtraction? So if I take the same example, and now I start taking this as a subtraction, well, it's going to be a little bit different in here. So for this, let me shift this out of the way. Okay, so I'm going to try to take this, and let's maybe make it a lot smaller, put it on the side. Let me take this, okay, make it smaller, put it on the side right here. So that was my resultant vector there. But what if, you know, you were doing something of this nature, that you had, okay, so here was your vector number 1, all right, so this is V1, so we know it's already 5. But now I want to be able to find, you know, V1 minus V2. Well, so what would you do? Well, remember that the subtraction just means the addition of the opposite. So this vector, right, so instead of going, so this vector that I have right here, so this one right here, if I duplicate it, bring it back, so instead of going in this direction, right, it doesn't go in this direction, it does the opposite. So it does a 180 degrees, okay, and it would head in that direction. So that would have been what we would have had. So I like to do that, and now my resultants, okay, so within here, what this would be is that it would head in this direction. So this is my resultant, okay, now, right there, and we can find out exactly what that is as well. So this would have been my R, and this right here, I'm going to put it in blue, so this is the negative V2, so that's the opposite of our vector right there. And because I didn't change the magnitude, so it's still going to be, you know, square root of 61 as my magnitude for R. But, of course, now my angle right here, so instead of, you know, being, okay, going up to the north side there, so this is actually going to be the same angle. Okay, so it's going to be east, so it's still, you know, 50 degrees rounded to the 1, but it is south, right? Because now it's the opposite. So that's how you're going to be running into additions and subtractions of various vectors, okay, within here. So that is how we would do these particular types of examples. Now, you can see here that we have horizontal and vertical vectors that I've just used, right? They're either going up or down. But that's not always the case, right? So we don't always have the case that these particular vectors are going to be either east or west, or they're going to be north or south. They can be going anywhere at any particular direction. But that shouldn't cause us any issues at all with adding or subtracting. So now let's take a look, okay, and then how we would be adding and subtracting, and I'm going to break it down into the x and y coordinates. So make them, okay, kind of go, you know, in the x and the y directions in terms of vectors. So here it is. So let me add another page in here, okay, again. And so this would have been in general. So in general, what actually happens in here? So let's say, you know, now I'm going to be dealing, okay, and here is my vector number 1, so 1, 2, 3, 4, 5. But this vector that I have now, okay, what it is, so instead, so maybe, you know, it's going in this direction, so something like this that I have. So now that is my vector, so this would have been my vector number 1. And now clearly it's not just horizontal or vertical, it's at some angle that I have. And in these cases, what I love to do is I love to attach a coordinate system, so to this. So I'm going to take this, okay, for instance, in this way, like so, and I'm going to attach it, okay, to my vector. So I'm going to go, boom. Here's my now vector, okay? So I don't know exactly, okay, what it is that it is doing. However, the way that I have drawn it out is I can see that this vector in particular, so what it has is, here is the x, component of that vector. So that is the x component of that vector. So we typically would write it, v1 of the vector, and this is going to be the x component. Sometimes you'll write it, in terms of a subscript. So I'll put a little subscript in here. This is the x component. So now that particular component, as you can see, so it is 1, 2, 3, 4. All right. So basically it's 4. So this, in terms of its magnitude, this is going to be 4. And let's keep it at meters, okay? So each box would be a meter. Now, the y component that we would have, well, the y component, okay, right here, it's going to be in the y direction. So this is going to be v1y, okay, of that vector. And now that is, 1, 2, 3 components. So if I would take v1 of y, take the magnitude, this is 3 meters. And that entire length, so this particular length of my whole V1, I can once again find out, right? So this, okay, is nothing else, but it creates an actual triangle for us. So we know this is 3, this is 4, and I can find out, so my V1 in terms of its length would be, and this is simply 3 squared plus 4 squared. Take the square root of that. And of course, it shouldn't surprise you. Well, because I made it to be equal to 5, okay, from the beginning. But that is the actual magnitude that I would have of that V1 vector. So you can break down each vector in terms of its components, right? So it can have an x component and then a y component. And once you have that, those x and y components, then you can start adding and subtracting the x and y components and then create your resultant one that you might have. So for instance, if I would create my V2, and my V2, let's say if it was something, like this was my V2 right here. This is V2. So it has an x component and it has a y component as well, right? Now this one, in terms of adding these two up, it's not going to be as easy. So notice, if I take this, I'm going to take I'm going to just duplicate it just so that you can see it. So really that is my V1, and then here is my duplicate V2. So if I was doing this, okay, this is how it would look like, correct? So that's what I would have had, okay, in here. And this is the actual result that I would be carrying out. So whatever that result might be. And this, okay, within here, so my result would have been this vector right here. So whatever that would be, that is my resultant vector of adding these two components up. So visually, we can see that, oh, okay, well, this is just V1 plus V2. Great. But now how do I actually find the magnitude and how do I find the actual angle, right? Or the direction that that resultant magnitude is heading in? That is something that I would want to be able to know. So within here, so if I take this through, and it looks like I didn't draw it all the way, okay, within here. So let me make it so that it actually attaches. Okay, so this one was actually a little bit longer. So this one is much easier to be able to find. Okay, so as you can see there we go. So in this case, look what happens to the y components. So the y component of my vector, so if I take this vector right here and I take the y component, well, that y component has 1, 2, 3, right? But it is down while my V1, so my vector V1 is 3, but it's up. So those y components are canceling. What I have is 1, okay, is going 3 upwards, okay, in this direction. That's from V1x. And then my other one, so that's going to be just the y component of V2. So notice this is V2x. Now it just so happens this is 1, 2, 3, and this one's 1, 2, 3. So the resultant is 0, right? So it's just a 0 vector in the y direction. And the only thing that's left there, now if you look at the x components, well, the x component of v1 is 4. And then the x component of v2, you can see there, it's just simply 1. It's one box, right? So that's what we would see there. So this is just that one box right here, as we're just heading to the left. So what you would have is, this is, so I apologize, this should have been y, because these are the y components, because it's the vertical. And then the x components that I have, so that one x component is 1, 2, 3, 4. That's the v1. That actually is the x component. And then the y component is only 1, okay, in this particular direction. So it's in the opposite direction in here. So it's going in this way. And of course, if I would shift it over, so if I take this, bring it back and put it from head to tail, it's going to bring me back 1 square. So what is going to happen is that my resultant is going to be right here. So that's my resultant right there. So the Vy is 0 and the Vx is going to be plus 3, and that's exactly what you see here. So this is going to be 3 meters at 0 degrees to the horizontal is my resultant. Now, is it always going to be 0? No, it won't be always 0, because what could happen is, imagine that if I would take my component, so this one, and I actually span it out. Let's say, maybe it was something all the way over here. It was heading in that direction. That was my actual V2. Well, now, if you would take that, so if I would take those two, so I'm going to just copy this. So this is my V. So here's my first, okay, and then here's my second one. So I'm going to duplicate that, bring it down. Notice that if I do this, well, now here is my resultant. So my resultant is going to be, okay, heading in this direction. So that's my resultant. And clearly, that is no longer horizontal. It does have an angle, and that particular angle, okay, would be measured from the horizontal point right here. So if I would graph, this is kind of a magical right there, okay, axes, and we can find what that resultant is, and then find out what that angle is right there, right? So that's what we would have, okay, for this one. And you can break it down into its x components and then its y components. So let's do that for this final one, okay, in terms of the additions, okay, and then we're going to kind of call it a day. So within here, so I'm going to do everything in blue. So this is going to be number 1. So this is for vector 1 right here. So I'm going to have its x component and I'm going to have its y component. And I'm going to find out what those values are. So the x components are, because it's all graphed, so this is 1, 2, 3, 4. So that's my, 4, and it's positive. Okay, I'm going to put the positive meaning to the right. My y component is 1, 2, 3. So this is also positive, right? So this is going up and to the right. So that is V1. My second one, so my vector number 2, so this is V number 2 right here. So in this particular case, so what I would have is I would break it down into its x component and into its y component right there. And now I can just test it out. Now I had it right here in terms of grafted on, okay? So I can count it. So that means that if I look in here, let me clean this up in here. So notice we are heading, this would have been x1, 2, 3. So it looks like it's 3, but it's negative, right? Because it's to the left. So it's 3 to the left on the x. And then on the y, this would have been 1, 2, 3, 4, 5, 6, 7. Okay, so we can say that it's 7, although it spans 2 pages. But let's say that it is 7. And it is down, so I'm going to put negative there. Let's make sure 1, 2, 3, 4, 5, 6, 7. Okay, so that's what it would be. Now, once you have those, now notice, then you can take your x components right here. You can find out what the resultant is. So number 3 is going to be for the green. So my resultant one, my x component is, well, 4 minus 3 is going to be plus 1. So this is what it's going to be on the x side. And then my y component of the resultant would have been taking my, so these two pieces, the y's, so that's going to be 3, and then minus 7, so that's going to be negative 4. So this is going to be negative 4, and there you have it. So now you have found what your resultant is. So it has your two components, and then we can find out what that is. So this particular line, if I bring it down in here, okay, so right there, so what we would have is that it goes down. So notice, so if I want to find out, so this is spanning, and this is the x, so that's 1, okay, and this is the y, which is 4, places down, so I can find out exactly what my magnitude is. So my magnitude is equal to, for this example, it's going to be 1 squared plus 4 squared. Take the square root of that. It's going to be 1 plus 16, so that's the square root of 17. Okay, so that's what I have right there. And now, what is the angle? Right, so in terms of the angle, we can do it from the horizontal. So within here, so from this line, so from the horizontal viewpoint, okay, what that angle is. So that's this angle that we're trying to find out. And that particular angle would be, okay, so within here, so you can do again. So for this, so tan theta, which is the opposite over adjacent. Okay, so that's going to be opposite over adjacent, so that's 1. That's your tan theta, and that angle is equal to, well, we can find out exactly. So tan inverse, this is just 4 over 1, which is 4, and it's going to be, I guess, around 76 degrees. So this is at 76 degrees, and now if we want to make it kind of accurate, because we have to provide the correct bearing, so this would have been, I guess, if we're starting from the east, from the left, and then we're going south. All right, that would have been that particular angle. So there you have it. So you can be adding, I mean, if you're subtracting, then you simply take the opposite and you play the same game. So, you know, you can certainly do that. So I hope that this gives you an introduction to adding and subtracting vectors. I love breaking them apart into the X and Y kind of systems. If you are able to have it on a grid like I did right here, you can always put them head to tail, okay, so that you can see what is happening with your vectors. So that is it for this particular example. So it's addition and subtraction. I'm sure more videos to come on this topic later down the line. Thanks for watching. We'll see you in a future video. Bye, everybody.